Most people think learning Python takes months of grinding through boring syntax and complex theory. But what if I told you there's a way to master Python fundamentals and start building real applications in just days? I'm about to show you the exact 3-step system that will take you from complete beginner to building your first functional app using Python and AI as your coding assistant. Here's what's crazy. In the first part, I'll teach you all the Python fundamentals you need to know, covering every essential concept from scratch. Then, in the second part, I'll reveal how AI can 10 times your learning speed and help you write better code faster than any traditional method. And finally, we'll put it all together by building a real calorie tracking application that actually works. But here's the thing. Traditional tutorials won't teach you this approach. Coding bootcamps charge thousands for this knowledge, and most beginners waste months learning the hard way without ever touching AI development tools. The question is, are you ready to learn Python faster than you ever thought possible? Because by the end of this video, you'll have both the fundamentals and the AI-powered skills that most developers are still figuring out. Let's dive in. When I first tried to learn Python, I spent more time setting things up than actually coding. Between downloading the right version, figuring out where to write code, and understanding what an IDE even does, it was confusing. Don't worry, this part is simple once you know what to do. Before you write a single line of code, we'll get everything set up the right way so you can focus on learning, not troubleshooting. Alright, we'll start by installing Python, which is the core programming language we'll be using for everything in this tutorial. Visit the official Python website by searching Python download page in your browser. From there, grab the latest version for your system. Once the installer finishes downloading, open it and then hit Install Now. The setup will guide you through a few quick configuration steps. Just approve any dependency installations that pop up. After a couple minutes, Python will be fully installed, ready to interpret and run your code. Next comes Windsurf, which is where all the action happens. Windsurf is an AI-powered IDE. That stands for Integrated Development Environment. It's basically your workspace for writing, testing, and improving your code. What makes it special is how seamless and beginner-friendly it is. Next, install Windsurf. Just head to the official Windsurf website, it's easy to find, and download the setup file for your system. The installation is quick and straightforward, and no extra setup or hidden configurations are needed. I already have Windsurf installed on my system, but if you're doing it for the first time, it'll be ready to go in just a few minutes. Once both Python and Windsurf are ready, you officially have your full development setup. Now we can start coding and write our very first Python program. So you got Python and Windsurf installed. Now comes the moment every beginner looks forward to, writing your first real code. Don't worry about syntax or making mistakes. Everyone starts here. In this part, we'll go over the absolute fundamentals of programming using Python. You'll see everything on screen as we build together. We'll begin with functions, the building blocks of every program. A function is like giving your computer a mini recipe. It follows your steps, produces a result, and you can repeat that process whenever you need it. You can see here a short Python script called first.py, where I define a function named greetUser. In Python, every function starts with a keyword def, followed by the function name and parentheses that can hold any inputs or parameters. In this case, the parameter is called name. Inside the function, I'm going to use the return statement to send back a formatted message that says, "Hello name, welcome to Python." Right below that, there's a line of code outside the function where we call another built-in function called print. Here, I'm going to pass in greetUser James, which means we're calling our function and giving it the value James. When the program runs, and you can see this as I press F5 on screen, Python takes that value, runs the greetUser logic, and prints out the message, "Hello James, welcome to Python." Now that we understand functions, let's move into something that you'll use in every single program: variables. A variable is just a container for data. It's how your program remembers information, things like names, numbers, or even whether something is true or false. In Python, creating one is really simple. You just type a name, add an equal sign, and assign it a value. Python automatically figures out what type of data that value is, so you don't have to tell it explicitly. Alright, I'll create a new file called second.py, and inside it, I will define a function called showVariableTypes. Inside this function, I will write 4 lines of code that each define a variable. The first one is age equals 25, which is a whole number. That's what Python calls an integer. Next is price, 19.99, which uses a decimal. That's a float. Then we have the name equals Python, which is a string meaning a piece of text. Finally, is_active equals true, which is a Boolean value. Basically, it can only be true or false. After that, I'll use a return statement to combine all this information into a single message that displays both the variable values and their types. You'll see that the code uses something called type open parenthesis variable name close parenthesis dot name. That's a built-in Python feature that tells you exactly what kind of data each variable holds. Lastly, I will print the result so we can see everything in the terminal. After I press F5 to run the script, Python prints something like age 25 int, price 19.99 float. Each label shows the value and the type. It's a simple script, but it teaches one of the most important habits in coding, which is understanding what kind of data you're working with before you start manipulating it. We've seen how Python handles data, so now let's start putting that information to work. Numbers are at the heart of almost every program, so this time we'll look at how math works in Python by creating a simple program that calculates totals. On screen, I'm creating a new file and defining a function called calculateTotal. The goal here is to build a simple program that takes a product's price, quantity, and tax rate, and then gives us the final total with tax included. Inside the parentheses right after the function name, I'm adding 3 parameters: price, quantity, and tax rate. These act as placeholders, meaning whenever we call the function later, we'll provide the actual numbers that fill them in. The first line of code inside the function multiplies price and quantity to get the subtotal. That's your base amount before tax. The next line calculates tax by multiplying the subtotal by tax rate, and the final line adds those 2 values together, giving us the total cost. Right before finishing, we need to wrap everything in a round function and set it to 2 decimal places. This tells Python to tidy up long decimals, keeping the output clean and readable, just like you'd see in a receipt. Below the function, I'm using print calculate total 10 to 0.05 to test it. That means we're buying 2 items at $10 each with a 5% tax. After pressing F5 to run the code, Python goes through each step, multiplies 10 by 2 for a subtotal of 20, calculates 5% tax, which is 1, adds it together, and prints 21.0 as the final result. This simple program teaches 2 key things: how math works in Python, and how even a few lines of code can automate a real-world calculation. It's clean, efficient, and beginner-friendly, the perfect example of logic turned into action. Now that we can calculate totals, what if we want to store more than one value at a time? Let's talk about lists, one of the simplest but most useful tools in Python. A list lets you store multiple values inside a single variable instead of creating separate ones for each item. Let's create a new Python file here and define a function called createShoppingList. Inside the parentheses, we don't need any parameters yet. This function will just build and return our list. Inside the function, I'll type items apples, bread, milk, eggs, cheese. Notice that the list is surrounded by square brackets, and each value is separated by a comma. In this case, each item is written as text, which means they're strings, one of Python's basic data types. Next, I will use the return statement to send the list back whenever the function is called. That means every time we run createShoppingList, Python will hand us this exact group of items. Below the function, I'll call it with print createShoppingList parentheses, and you can see that on screen. This tells Python to execute the function, take whatever it returns, and display it in the terminal. When I press F5, the output shows the entire list: apples, bread, milk, eggs, and cheese, all wrapped in square brackets. This confirms that Python recognizes them as elements in one list, not 5 separate variables. Lists like this become the foundation for working with larger datasets, loops, and even user inputs later on. It's your first step towards writing code that feels structured and scalable. But lists are only useful if you can access the data inside them. Python lets you grab any item by its position number. You'll see a simple function here called getListItems. Like what I said, this function takes a list at its input and pulls out specific pieces of data using something called index numbers. In Python, indexing starts at 0. That means the first item is at index 0, the second is at index 1, and so on and so on. You can even count backwards using negative numbers, where -1 gives you the last item in the list. For instance here, the function retrieves 3 things: the first item, the last item, and a small section from the middle using something called slicing, which lets you grab a range of values at once. Here we have a list called fruits with 5 elements: apple, banana, cherry, date, and elderberry, and passed it into the function. The slice, written as 130, means start at index 1 and stop before index 3. So Python returns banana. The slice, written as 1:3, means start at index 1 and stop before index 3. So Python returns banana and cherry. When the code runs, the program outputs the message showing the first fruit as apple, the last as elderberry, and the middle items as banana and cherry. This step shows how Python lets you organize and retrieve data precisely where you need it. Lists aren't just for storing, they're for working with data dynamically, one piece at a time. And now that we can access and work with data, it's time to make our code think by adding logic. This is the part that lets your program make decisions using if and else statements. In Python, if checks whether something is true. If it is, that block of code runs. Elif, which stands for else if, checks another possible condition, and else runs only if none of the others are true. It's how Python evaluates logic, one check at a time from top to bottom. You can see here I'm putting up a simple function called checkGrade. Inside it, the structure is pretty straightforward. It starts with the keyword if, followed by a condition. In this case, if the score is greater than or equal to 90, return A. If it's not, move to the next condition. If it's 80 or higher, return B. The program continues checking each condition: 70 for C, 60 for D, and finally, if none of those are true, it returns F. Each block of code under those conditions is indented, which is how Python knows which lines belong together. Below the first check, there are several elif statements, short for else if. These act like checkpoints, letting the program test other conditions one by one. Lastly, there's an else block at the bottom that runs only if none of the previous conditions are true. This setup gives the function a clear flow from top to bottom. If we run the program with a score of 85, Python checks each condition in order. It skips the first one because 85 isn't 90 or above, moves to the next, sees that 85 is greater than 80, and immediately returns the result B. The rest of the code is ignored because once Python finds a true condition, it stops reading further. If-else statements are one of the most important ideas in programming. They're the difference between a program that just runs instructions and one that responds intelligently to what's happening. The first real step towards building logic into your code. Now that we've learned how to make decisions in our code, let's make it handle repetition automatically. For loops are Python's way of saying, do this for every item in the list. It's a simple but powerful concept. Instead of writing multiple lines for each item, you just write the logic once and Python does the rest. Let's create a new function called count_items. Inside it, I'll start by setting a variable named total to 0. That's going to track how many items we've processed. Then let's add a line for item in items, which tells Python to loop through each item in the list one by one. Everything indented underneath that line runs every time the loop repeats. In this case, we add 1 to total using total plus equals 1, and then print a message that says which item we're currently processing. After finishing the loop, the function returns a short message with a total count. Below the function, we'll create a list called products that contains laptop, mouse, and keyboard, and then we'll call count_items parentheses products. When the code runs, Python loops through each item in that list and prints processing item 1, laptop, processing item 2, mouse, and processing item 3, keyboard. Once the loop finishes, it prints total items processed, 3. For loops are one of the most useful tools in programming. They let you automate repetitive work, keep your code clean, and handle lists or large datasets with just a few lines of logic. At some point, every beginner hits that same wall. You understand the basics, but actually building something starts to feel intimidating. You know what you want to make, but you're not sure how to turn that idea into working code. We will be needing the help of AI here. In this part, we're going to explore how Windsurf's built-in AI assistant, Cascade, helps bridge that gap. It's designed to make coding feel less like writing instructions line by line and more like having a real conversation with someone who knows how to code for you. Inside Windsurf, we'll open Cascade, and right away, you'll notice how natural it looks. It's a chat interface built directly into the IDE. You can talk to it in plain English, describe what you're trying to build, and Cascade instantly translates your ideas into working code. You can even choose which AI model to work with depending on your needs. Now, to get things started, I'll ask Cascade what it actually does. You'll see its response appear on screen, a breakdown of its abilities that goes far beyond simple code generation. Moving forward, you'll start to see how much this changes the learning experience. You don't have to memorize syntax or worry about small mistakes. You can stay focused on the big picture, how your code actually works. In the next part, we'll put that to the test and ask Cascade to build our very first Python program from scratch. But before we start building, it's important to understand how AI actually fits into the process. The way you communicate with it, through something called prompts, determines the quality of what it creates. These are like instructions you're giving to a really smart coding partner. The clearer and more specific you are, the better the results you'll get. Good prompts explain exactly what you want the AI to do, what inputs it should take, what outputs it should give, and any extra details that matter. Clarity helps Cascade understand your intent and write accurate, usable code. In short, clear instructions equal clean results. And that's what we'll be applying in the next steps as we start generating our first function with AI. Time to put Cascade to work. For our first hands-on test, we'll ask it to build something simple, a random number generator. It's a small project, but it will perfectly show how quickly Cascade can turn plain English into working code. Let's type in this prompt. Build a random number generator that asks for the user to input a max and min value. Then have the program give a random number between these parameters. Cascade processes the request for a few moments, then instantly generates the full Python script right inside the project window. Everything from user input to random number logic is ready to go. Let's run the code, and just like that, it works. The program asks for a minimum and maximum number, then prints out a random result between those values. What's impressive here is how little effort it takes. Like what I said earlier, we don't have to write the function line by line. Cascade handles the syntax, imports, and structure automatically. In just one prompt, we've created a working piece of code, and that's the foundation for every build we'll make next. After testing our first function, it's time to level things up and build a complete program, something that actually looks and feels like an app. For this next step, I'll ask Cascade to create a simple to-do list application. Let's tell Cascade to build a to-do list that allows users to add tasks, view tasks, delete tasks, and mark them as complete. Create a full UI for this application and make it look good. Cascade starts generating, and within moments, we have a full Python desktop app, complete with a graphical interface. It's not just code this time, it's a working program with buttons, lists, and functional task management. Let's try to run the app, and it opens instantly. But like any real development process, not everything comes out perfect on the first try, and that's completely normal, even when you're working with AI. In our case, the to-do app works, but the button text blends into the background and isn't very readable. So instead of manually tweaking the code, we'll just ask Cascade to fix it for me. I'll type in this prompt. Thanks. Please improve the design further and make the button's text readable, as the text color is white. The update only takes a few moments, and after we run the app again, the difference is clear. The design looks cleaner, the text is easy to see, and the overall layout feels more refined. After building smaller tools like the random number generator and the to-do list, it's time to bring everything together into a real usable project. This is where things start to feel exciting, because we're not just writing code anymore. We're gonna build something people can actually use. For the final part of this tutorial, we're going to create a Calorie Tracker app, the kind of simple, everyday program that shows how powerful Python becomes once you pair it with AI inside Windsurf. Let's begin by setting up the foundation. I'll open Cascade and type the first prompt. Hi Cascade, please create a Calorie Tracker application. For starters, create the UI and make this a Windows app. We'll build functionality afterward. Right away, Cascade starts assembling the layout, a dashboard, an Add Meal section, and a History tab for logged entries. After running the first version, the app opens with a clean, minimal interface that already looks like something you could use. It's basic for now, but it sets the stage for what's coming next. Design always matters, especially for an app people interact with every day. So our next step is to make it visually appealing. Let's tell Cascade to please further improve the design. Give it a more modern look. Cascade refines the visuals and adds details that instantly elevate the app. Smoother layouts, clearer typography, and even light and dark modes that switch seamlessly. The dashboard becomes easier to navigate. The buttons are more responsive, and the interface now looks like something straight out of a polished desktop suite. Now that the design is done, let's move on to the most important part, making it actually work. I'll send one more prompt. Great job! Now please build the actual functionality of the application. Create the macro tracker function where the user can list their food and its macros and have it reflect on their calorie goals. Allow the user to set their target macros and goals. Cascade connects all the logic behind the scenes. After we run the app again, users can now input meals, calories and macros, proteins, carbs, and fats, and see how each entry impacts their daily goals. The totals update live, the dashboard reflects progress in real time, and everything works exactly as expected. You just watched what learning Python really looks like in 2025. Not weeks of staring at syntax, by building real projects side by side with AI. This is how you learn to code today. Every line you write, every prompt you test, teaches you more than any tutorial ever could. If you're ready to keep building, the links to Windsurf and the project files are down below. Open it up, start coding, and see how far you can go with AI as your coding partner. Thanks for watching, catch you in the next one.